Hello everyone, welcome to Unit 2, Day 11. We're going to continue our studies of writing the equations of lines. So we're going to kind of pick up from where we left off last week, where I might give you a graph and ask you to find the equation of a line using clues from the graph to write that equation. And then we're also going to take a look at applications of lines. So where do we see these lines present themselves in typical everyday problems or scenarios and things like that. And we'll learn how to pick the slope and the y-intercept out of those scenarios today. All right, so just a bit of review here from last week. We talked about the building blocks of lines. We know its equation form, which is y equals mx plus b. And we know that inside of that equation there are two major pieces. We have the slope, which is represented by m, and then we have the y-intercept, which is represented by the b value inside of the equation. On a little bit deeper level, we talk about the slope. On a graph, it typically tells us what the steepness of the line is. It gives us a general direction of the line in terms of something called rise and run. Rise being the change in the y's and the run being the change in the x. So in other words, rise represents the vertical change, run represents the horizontal change. All right. The y-intercept is a location where the line crosses the y-axis. So when we go to our graph and we look at that line, we look for where that line hits the y-axis on the graph to determine what that b value is going to be. All right, so let's give it a try. We tried one of these problems last week. In a previous lesson, Mr. Rolls showed us how to graph a line if we were given the equation. So equation to graph, pretty easy. So in this problem, we're going from graph back to equation. All right, so here we go. We have a line presented to us. The first thing that we want to find its slope. And to do this, we need to find 2 points that are on the graph. Okay, and you can use any 2 points, but I would recommend that you find 2 nice, easy points, something that lands right on these integer values here. So I'm going to pick, let's say I pick this point right here, and let's say I pick this point right here. And like I said, you can pick any 2 points to do this. You're going to get the same slope either way. You might get a fraction that looks different, but once you reduce it, you'll get the same number. Okay, so to find our rise and our run, we complete a slope triangle here. So my rise, like if I were traveling from this point to this point, I'm going to go down like this. So that's my vertical change. That's the change in y. And then my horizontal change going from right to left. So I'd have to go left at this point over to that second point. So this represents my run. That's the change in x. Okay, so I'm going to count those out now. I went down 1, 2, 3, 4. So there's my rise. And then I went over 2 here. So I'm going to put a 2 there. Okay, so I can see my rise, I can see my run. I'm going to come over here and write those numbers. So I'm going to say 4 over 2, and then I can reduce that fraction, right? So there's a common number that goes into both of those, and that would be 2. So if I took 4 and divided by 2, I would get 2. And if I took 2 and divided by 2, I would get 1. And 2 over 1 is simply 2. Okay, and I would accept any of these. Okay, so if you find a slope and you don't reduce the fraction, for now, I'm not gonna get upset if you don't reduce the fraction. I'm just hoping that you can find the slope if I gave you a graph. Okay, but any of these would be good. All right, so now let's find the y-intercept. So we are looking for the point on our graph where we are crossing over the y-axis. So I'm going to switch colors here, and I'm looking at my blue line. The y-axis is this vertical axis that runs through the middle of the graph. Okay, this is y. And the horizontal axis over here, this is x. We're looking for where the line crosses the y-axis. So I see it right here. It hits the y-axis at 4. But remember, this is a point, so we need to make sure that we say 0, 4. This is my y-intercept. So I'm going to come over here and I'm going to say 0, 4. All right, so now I got my y-intercept written as a coordinate, complete with a comma and a set of parentheses here. And then you'll notice that a difference from the problems we did last week, I added in this b value, and that's because I don't think I made it clear where the b value comes from, right? The difference between the y-intercept and the b value needs to be discussed a little bit. The b value is this number. It is the y-coordinate of the y-intercept. So specifically, b is 4. 4, and it comes from this part of the coordinate. So if they're asking for a y-intercept, you want to write it as a point like this. If they're asking for the b value, you want to extract that number from the coordinate and just write the number. Okay, so there is a difference between when they ask for the y-intercept and when they ask for the b value. All right, so now I can write my equation. Remember, y equals mx plus b. So I'm going to say y equals m is 2, or 2 over 1, or 4 over 2, whichever one you decide to go with here. I'm just going to go with the 2. So we're going to say 2x, right? There's mx plus b. And my b value was 4, so there is the equation of my line. Y equals mx plus b. There's my m, there's my b. I found those both from the graph over here, and that's how it's done. All right. Okay, so let's move on a little bit. Now let's talk about where do we see this stuff in real world applications? Like how does it present itself? What does it look like? Well, in a real world context, when we talk about the slope devoid of the graph, the slope usually represents some type of growth or rate of change. We're looking for something to grow, or maybe not even necessarily grow. Maybe it's going to shrink, who knows? But we're looking for some kind of change to happen in the problem, and that change is measurable. All right, so some examples, like maybe you plant something and it grows 3 inches per day. All right, so we look for our clues here: 3 inches per day. And if I were to write that as a slope as we know it, where we have a rise over run, we would say the rise is 3 and the run is 1 day, right? So we get 3 inches over 1 day. All right, so we would look for something like this in our word problem, and then we would translate that into something numerical that we can work with, like this. Okay, another example might be a bank account problem, right? You have a bank account and it tells you it grows by $8 every 3 weeks. Okay, so we have a bank account, it's growing, right? We see growing and $8 every 3 weeks, right? So that means it's going up $8. So there's our rise every 3 weeks, and that 3 weeks represents your run. So 8 over 3 becomes our slope. All right, you might remember our problem about Mr. Camacho's bald spot. Okay, and I don't remember the exact rate of growth, but we're going to pretend that it was 4 centimeters every hour, right? So it's growing again by 4 centimeters every hour. So it's going up 4, right? So there's our rise, 4 over 1 hour, 4 over 1. Okay, so we take these verbal descriptions of some type of growth or change, and we change the verbal description into something numerical that we can work with. Okay, now the y-intercept usually presents itself as an initial value or a starting point, like a launching point for your problem, right? So if we're talking about the plant, right, you have to put the plant in the ground. Well, how tall was it when it went into the ground, right, before we started measuring its growth, right? So your plant is planted in the ground at a height of 5 inches. We would need this piece of information in our word problem, and when they give you that, they're telling you what that y-intercept is, right? So we would know this is starting off on day 0. It's 5 centimeters or 5 inches, right? Day 0, 5 inches, which means the b value for our equation is 5. All right. The bank account problem, you initially deposit $80 and then it starts growing. Okay, so initially it's 80, right? So that means on day 0 or week 0, when you deposit your money, you had 80 bucks, right? Which means our b value is 80. All right, so that's what we're looking for in these word problems. All right. So let's take a look at our first example here. Let's see if we can read through this a little bit. It says you have a new cell phone and you want to determine how fast the battery drains. All right, so you unplug your phone and you start recording data you start recording the following data in your table below. Okay, so we unplug the phone and then we start monitoring the battery level in percentage, right? So when you look on your phone, you want to see how much battery you have left. And I say it has 90% left or 80% left, whatever it is. And we're going to go every hour. Every hour we're going to check our phone and see what the battery level is. All right, so according to our table, 1 hour after I unplug it, the battery level was at 95%. Then at 2 hours, we're at 90%. Then at 3 hours, we're at 85%. And you might say, okay, I'm noticing a pattern here, right? If I'm looking at the change in my y values here, where y represents the battery level, it's going down by 5% each time. Okay, so it's going down by fives. So I can probably fill in the rest of this table. After 4 hours, I would guess that it's going to be at 80%, and then after 5 hours, it'll be down to 75%. And then you'll notice over here at 0 hours, right, when we first unplug it, so as soon as I pull the charger out of the phone, right, this would be at 100%, right, and so that hasn't drained at all. And you see it going down by 5%. Okay, so now we can actually take this table and we can plot it over here on our graph, right? So our first point here being 0, 100%. Okay, and it might even be worth your time to label your axes down here. So remember that the x's are representing hours, and the y's over here is representing battery level. Okay, and our phone, as soon as we unplugged it, started at 100%. So we get our first point up here. This is 0, 100. And then after 1 hour, it goes down by 5%. So that would be right here. And then after 2 hours, it goes down another 5%. So we're at 290. And again, these points are just coming from the table that I have up above. All right, so after 3 hours, it goes down another 5%. And you start to see your line taking shape here in the graph. All right, so then at 4, we're at 80%, and then at 5, we're at 75%, and then at 6, we're at 70%. Okay, so we got all of our data points here, and then I would draw my line. Oh, that's horrible. I can do better. Let's try again. That'll be close enough. Maybe I couldn't do better. There we go. Oh, we just need to make it longer. That works. There we go. So there's our line going through our points. So we can see that the line is going downhill here, so that would indicate a negative slope. All right, so I'm going to remember that for later. All right, and then I'm going to try and answer these questions off to the side, right? So how much does your phone drain every hour? It drains 5%. We notice that 5% per hour is how much the phone drains. All right, and we got that right from our table. How much charge did your phone have as soon as you unplugged it? Well, if it was fully charged like ours was, it was 100% when we unplugged it. Okay. What is the equation that represents the drain of your cell phone battery? Okay, so again, they're asking for the equation here, and we know that this is a line, so we know our equation is going to look like this, right? So y equals mx plus b. And if you think about the questions that they ask you here, how much does your phone drain every hour? This is code word for slope. What is your slope? 5% per hour, right? So we would say 5 over 1, just like that, 5 per hour. Okay, so this is something we need for our equation. How much charge did your phone have as soon as you unplugged it? Well, that's the initial charge, right? So as we started observing it, it started at 100%, right? So this is our B value, right? So we would say B equals 100. And it's convenient that we have those two things because that's what we need for our equation. Okay, so as I write my equation here, I say y equals, well, here's my slope, so I'll just say 5 over 1x, and if you just want to put a 5 there, that's fine, plus my b value, and my b value is 100. So there's my equation. Now, I did make a mistake here because I forgot to say it's draining, right? So it's going down, so it's actually going down negative 5% per hour. So I'm going to put a negative in front of there. And remember, our line was going downhill. I even made a mental note that this was going downhill, so this should be a negative slope. So I just need to make sure that I put a negative in front of that 5. Okay? So there's my equation. Now it's asking how much charge will your phone have after 8 hours. All right, no problem. So they are giving us an amount of time, and we want to make a prediction about what the battery level will be after 8 hours. So I could take that 8 and I could plug it in for x, because remember x represents hours, and I could say y equals negative 5 times 8 plus 100, right? So the x gets replaced with the 8, and then we calculate. So negative 5 times 8 is negative 40. And then negative 40 plus 100 is 60. So that is telling me that my charge level, or my battery level, is going to be 60% after 8 hours. So I put 8 hours in, got 60% out. All right, guys, that's it. That's an exploration of an application that involves lines. I hope you found it helpful. If you have questions, make sure you ask myself or Mr. Rule in the Zoom chat. Have a great day.